Dear Chairman, dear colleagues, my name is Rustam Yarulin. I am from Kazan Scientific Center of Russian Academy of Sciences. The title of my talk is Failure Analysis of an Aircraft GTE compressor disc on the basis of imitation modeling principles. My co-authors are Professor Valery Shlenikov and PhD student Ivan Ishtirakov.
Keep trying.
The outline of my talk is the following. First of all, will be introduction. Then I'm going to show you our practical and theoretical background. The next will be subject of the study. After that, I'm going to tell you about our numerical and experimental results. And after that will be discussion, short outlook, and conclusions. The gas turbine engine and compressor disc are an integral component to a gas turbine assembly, and their failure can lead to the aircraft catastrophic damages. The most common in Russia, the 46 gas turbine engine you can see in this picture. Experience shows that the critical zones of the compressor disc are a potential source of damage. So prediction of fatigue growth from critical location in a rotating disc is one of the parts of the tolerance damage strategy. So the main aim of this work is verification of the aircraft GTE compressor disc lifetime prediction model based on an imitation modeling approach. Well, what is imitation modeling? The first works related to imitation modeling approach appeared in Soviet Union from in the 80s. Electrohydraulic stand was a powerful tool for studying the disc service life. The critical fracture locations in turbine disc was modeled by both hole spacemen, which cut out from turbine disc. Our lab have a good experience in the residual life assessment of turbine disc and turbine blades with taking into account accumulated damages in service. So the main idea of the imitation modeling consists in testing of specimens or imitation models which are cut out from investigated failure critical components. The basic principle of imitation modeling are the following. First of all, the stress-strain state of the critical zones for both the real structural elements and imitation models should be the same. The correct initiation zone, correct path, and correct inclination should coincide with observed in structural elements. And the loading conditions of imitation model should reproduce a periodic loading profile. It is allowed to design and manufacture the imitation models from the same structural material for strictly according to manufacturer drawings for verification and calibration new correct growth rate and lifetime prediction models. In our study, we used the correct growth rate model which proposed by Professor Shlenikov. This model based on the fracture process zone and plastic stress intensity factors concept. Plastic stress intensity factors is a nonlinear fracture resistance parameters which is sensitive to the plastic properties of materials by means of IN integral. So for correct using the proposed correct growth rate and lifetime prediction model, we used correctly determine the distribution of fracture resistance parameters for correct body. The subject of our study is the high pressure compressor disc of DA36 gas turbine engine. Failure occurred in a disc and blade dovetail attachment. This compressor disc was produced from the titanium alloy, which mechanical properties you can see in this table. According to the first principle of imitation modeling, And the first part of our numerical study is concerned with stress strain state analysis of compressor disk itself. Finite element model for the compressor disk with place you can see in these pictures. Our numerical calculations shows that the maximum equivalent stress distribution occurred in a disk and blade ductile type attachment near the outer surface, and the maximum value of these stresses equal to 1,100 megapascal. So, and this value of maximum stresses exceeds the yield stress of the material. According to the the next part of our numerical study is concerned with development of imitation models geometries. Experience shows that the crack in compressor disk can occur in any slot fillets of keys. So we can consider the geometry of one ductile type attachment as an imitation model. So we developed two types of imitation models. The first imitation model was supposed to be used on standard test machine by uniaxial loading, and the second imitation model should be more accurately reproduce the biaxial loading conditions in compressor disk. And each of models needs fully reproduce the key slot geometry. And tension loading is applied by special designed loading fixture. The finite element mesh for both models you can see in these figures. Iteratively it was found that the tension loading equal to 14 kilonewton should be applied to the imitation model number 1. The imitation model number 2 needs to be loaded with forces along two axes of 19 and 38 kilonewton respectively. In these figures you can see the distribution of elastic plastic stresses for both imitation models. It should be noted that this similar pattern was observed for both for all stress distribution, but the equivalent local stress values around the slot key area are the same and coincide with the maximum value of equivalent stresses in the compressor disk. So the first principle of imitation modeling was realized. The next part of our study is concerned with manufacturing of imitation models and loading fixtures and further testing of imitation models. Both models was produced from the titanium alloy, and the key slot geometry of the disk and blade ductile tap attachment was fully reproduced for both models strictly according to manufacturer drawings. The imitation model number 1 was considered, the fatigue test of imitation model number 1 was considered by means of uniaxial testing machine, and the fatigue test of imitation model number 2 was considered by means of biaxial loading machine. And the crack growth was monitored by optical microscope. So in this slide you can see the results of our experimental study. The crack path obtained experimentally on imitation model 1 do not replicate the real compressor disk failure, but this imitation model is more suitable for experimental determination of durability at the stage of formation of macro defects. The imitation model number 2 makes it possible to study the crack growth rate and inclined crack path prediction under biaxial loading condition. In this slide you can see the quantitative comparison of the crack path and fracture surfaces for imitation model number 2 and compressor disk. You can see that it is clear that the biaxial loaded imitation model number 2 most accurately reproduce the state of the critical zones of the compressor disk at operation, and fully agree with second principle of imitation modeling. The detailed fracture surface analysis for both imitation models you can see in this slide. Two different stress ratio were applied several times to fix current crack tip position. And the crack propagation process can be divided into two stages. On the first stage, the quarter elliptical crack described by surface cracks, and on the second stage, quarter elliptical crack become a through thickness crack. So, on the base of measurements of the crack length on the free surface and obtained crack tip positions, we can find the functional relations. That is the crack length versus fatigue life for through thickness cracks, and aspect ratio versus number of cycles and relative crack length for the surface cracks. As I mentioned above, for correct using the crack growth rate model, we can determine the fracture resistance parameters along experimental crack fronts. So, to this aim, in general, 6 finite elements models with different crack front positions were analyzed on the basis of the corresponding static and material properties and range of the loads, range of the testing loads. So the distribution of elastic and plastic stress intensity factors you can see in this slide. Upper row figures correspond to the surface crack fronts, and bottom row figures correspond to the through thickness crack fronts. So, on the basis of obtained experimental data, we can verification our crack growth rate model. In this figure, you can see the fracture crack growth fracture diagram for corner, for surface crack, and through thickness cracks. And in these pictures, blue point correspond to the experimental data, solid line is the prediction. So we can see a good agreement between them. And some words about outlook. We are planning to manufacture the third imitation model, which fully reproduce not only the compressor disk critical zone, but also disk rim geometry. And we are planning to comparative test under a program test cycle, which is equivalent to the flight cycle of airplane. And the aim of this test is realizing the third principle of imitation modeling. And conclusions of my work. Two configurations of imitation models were designed on the basis of full-site predefined element analysis. It is demonstrated that the biaxially loaded imitation model number 2 most accurately reproduce the state of the critical zones of the compressor disk at operation. The functional relations between crack sizes, aspect ratio, and numbers of cycles was determined. And the proposed method of imitation modeling for assessing the lifetime of GTE compressor disk has considerable practical importance. So thank you very much for your kind attention.
We can take